topic today is Chesapeake Bay Health, what causes positive and negative trajectories. So as a brief introduction to what STAR is, the STAR lectures represents the Science, Technical Analysis, and Reporting Group of Chesapeake Bay program, where we are integrating between the goal implementation teams and the various data providers. So STAR is facilitating the dialogue between those, and the seminar series is a way to provide ideas and challenge people to be thinking about issues related to Chesapeake Bay. So these lectures have a goal of providing concise, 15-minute, thought-provoking ideas related to Chesapeake Bay science and management. And our rules of engagement is 15 minutes, which can be captured on video and posted on the Ian website. And our videos are released under Creative Commons license, so they can be freely shared and reposted on other websites. So we're going to encourage people to put their ideas out there that other people can share and discuss. So the idea that I want to present today is having to do with the Bay Health Index that we've been developed as part of the EcoCheck, NOAA, University of Maryland Center for Environmental Science partnership, in which we take three indicators of water quality: chlorophyll A, dissolved oxygen, and water clarity, establish thresholds for those three water quality indicators, three biotic indicators, the aquatic grasses, bottom dwellers, the benthic index of biotic integrity, as well as a phytoplankton index of biotic integrity, and combine these three water quality and these three biotic indicators into using these thresholds, measuring their ability to achieve those guidelines, and then create a water quality index and a biotic index that we combine together into a Bay Health Index. And graphically, it looks something like this. We get these maps of data collected monthly from 160 some sites around the bay for the three water quality parameters, and then mapping for the grasses that we do with aerial photography and ground truthing, and then a separate set of mapping exercises and sampling exercises with the benthic and phytoplankton. Combine this into threshold comparison and generate these combined indices. And then from these indices, we generate a report card ranking. We use a numerical 1 to 100 scale for water quality and biotic index, and we take the average of those, and then we plot those on a Bay-wide map, and we assign a letter grade based on a grading scheme that's pretty liberal. We have 20-point windows for each of the different letter grades, and you see a diversity of grades. And the thing that struck us early on, and you know, this bay is a very well studied bay and we have a lot of information, but this emergent properties that we started to see in looking at that, and I'll take two examples: the upper western shore with the highest grade last year of 64% of attainment of those from those six indicators, and the upper eastern shore, and they're physically adjacent to each other. You can take a small canoe ride across and get from the upper eastern shore, which includes the northeast Bohemia, Elk, and Sassafras, and Chester rivers, and compared to the upper western shore, the Bush and the Gunpowder, and you see a very large divergence of those scores. And so this was somewhat perplexing, but what we also were able to do is, because we established indicators that the Chesapeake Bay program had been collecting for over 20 years, we could back calculate those assessments. And when we did that on the Bay-wide scale, back calculate, we see that there's no major trajectory. It's pretty much going up and down. Dry years and wet years are clearly influence the overall rankings. But there was no specific trajectory for the Bay as a whole. But when we started to look at the trajectories of individual regions, what we found, lo and behold, was that there were didn't have a significant trajectory, but several did. And for the combined Bay Health Index, we had statistically significant correlation coefficients that were positive. In other words, getting better for the James River, for the Upper Bay segment, and the Elizabeth River in Virginia. And we had statistically significant negative trajectories for the Mid-Bay, the Upper Eastern Shore, which I highlighted earlier, and the Lower Western Shore of Maryland, the Severn, the South, the West Road, and the Magothy, and quite high correlation coefficients as well. So therein lies the issue that I want to address here in this lecture. So let me just drill into two examples, and I'll go with the Upper Eastern Shore, and remember that was a significantly negative Bay Health Index, R squared of minus 0.29, devolving that into the Biotic Index, also 0.29, and the Water Quality Index, 0.27. And you can see the water quality data in blue stretches back further than the biotic health, because we did some of these programs were only initiated in about 1996. But you can see an overall negative trajectory from the water quality, and then picking up with the Bay Health Index. So not only was this grade that we calculated 27 for one of the lowest in the Bay, but it's getting lower. So it's low and getting lower.
Bill, when you did the R-squares, did you do?
Let's.
I'm sorry, for the whole time period, for all of them, or?
The R squared that we calculated were for the time period of record available. So they were shorter for the biotic and throughout the total time period. Let's have a look at what the Upper Eastern Shore watershed is doing, and it's very rural. And this is a aerial photo of the Sassafras River, and down here is an aerial photo of the Chester River. There are a couple towns, Centerville and Chestertown, but relatively small towns, up into Delaware and in the far northeast corner. Lots of agriculture, poultry farms, and some forested areas up in the top. So there's no immediate smoking gun for degrading, continually degrading water quality up there. It's not a rapid growth area. It's been this rural character over the 25 years of record. Let's look at the Upper Western Shore, and this is actually didn't come up in that analysis of positive trajectories for the Bay Health Index. It wasn't significant, but it does come up for the Water Quality Index. You can see why it didn't come up as positive, because it's noisy. But looking across the water quality, the blue line is statistically significantly improving, and even though it's noisy, I think you can follow, your eye can follow that positive trajectory. These areas that came up as the #1 score in the 2008 report card also comes out to be good and getting better. So let's have a look at what's going on in that watershed. What could be happening that's actually changing over 25 years to make it improve? That's a tough question. If we look aerial photos, looking at the Susquehanna Flats and down onto the mouth of the Bush River, what we see is Aberdeen Proving Ground, one of the largest military bases on the shores of Chesapeake Bay, which have a lot of wetlands associated with them. So there's a nice natural filter of salt marshes at the mouth of the rivers, both Bush and the Gunpowder. So that's one part of it. Again, it's a largely rural character, but it does have the I-95 corridor with Bel Air and other priority. They call it a priority funding area. They have a relatively concentrated growth. It's not a total sprawl throughout the watershed. And the two things that they've done there quietly and efficiently are upgrade their sewage and, more subtly, their sewage overflow problems. So they put in infrastructure to improve their sewage treatment and their sewage overflow issue. And talking to some of the river keepers around the rest of the bay, that overflow issue permeates a lot of the degradation that goes on. So, I'd like to, we took Governor O'Malley up to the Bush River because he wanted to see one of the areas that were improving, and he asked a pretty relevant question: why are some areas getting better and other areas getting worse? And so that he would like to use the answer to that question to help focus and prioritize where the trust fund and the various cleanup initiatives that the state of Maryland is employing to do that. And I feel quite inadequate in answering the question. We can talk about the different land uses, but these are trajectories. Remember, these are things that are changing over time. So, you know, we've got to, and they're physically adjacent and yet have very divergent patterns. This upper eastern, upper western shore. And if we look baywide, similarly the James, why would the James be getting better and the Rappahannock languishing? They're physically pretty close, and you don't see, there's no obvious change in land use or BMP, best management practice implementation that would promote that. So this is a challenge. This is an open question. I don't have the answer, but I'm posing this question, and I think what I'm looking forward to is the discussion of what some of the possible answers to this could be. For reference, I'll point you to a paper in Marine Pollution Bulletin by Micah Williams et al., who has the data that you analysis and methodology of the Integrated Bay Health Index, and the EcoCheck website, which has the ability to go region by region, tributary by tributary, and calculate or generate graphs of not just the combined indicators, but the individual indices, the chlorophyll and the dissolved oxygen and the clarity that go into the water quality index, for example. So that gives you a chance to drill down and explore that. I want to acknowledge the team at the Integration and Application Network who've been, particularly the EcoCheck crowd, who's been working at developing those tools and integration, as well as the Chesapeake Bay monitoring team, for whom received an A+ for their efforts in developing these report card technologies and communication techniques. And then finally, we'll post this talk and this broader challenge on this website and do this for the series, this STAR lecture series.